yes, I'm going to present Edge AI, maybe not in the regular like data center edge style, but Edge AI in physical products. So, some baseline first. We have seen this Internet of Things happening from, let's say, the early 2000 until now. So started by connecting our desktop machines and possibly some not so smart phone, like some Eriksson or Nokia phone. These were the smartest phone at the time. After that, we saw lots of home equipment. It was your PlayStation, maybe the fridge, lots of things that, and also, of course, the smartphone came. Also kind of an IoT devices, very connected. It was also the TV set, many other things, but typically media devices. Recent years, we've seen everything getting connected. It's like your toys, it's the automowers, like these Husqvarna things moving in your garden. It's also a bit of cars, all sorts of household equipments, maybe your oven, your fridge, and all sorts of things in your home. And the next step that we kind of see now is these even more autonomous devices, which require even more computing and edge computing, of course. This is like robot dogs, humanoids, other types of robotic things, basically, doing more and more automation. So why do we see this edge computing coming around now? I've been working with IoT 15 years, more or less. And the devices was like this one before. It's like a 16-bit, very low power microcontroller with 50K of flash for program and 10K of RAM. And we squeezed in web servers and IP stacks and all of that into that. But now, it's looking like this instead. It's a small, even smaller device, actually. But you have a full Linux. You have a camera built in. You can do on-the-edge computing here. So you can actually do object detection in this. So what's happening right now is that we get lots and lots of more data, more sophisticated sensors, more and more capabilities in the devices, which means that you can put in AI models into the physical products, into the devices. And there's a lot of examples of this. If you look at the bigger part there, that's a edge rack that we are doing at RISE in Luleå, like a complete rack where we have very, very large capabilities. So you can do very powerful computing. But the other smaller one here is also like the NVIDIA small Raspberry Pi style sized AI thing that you can put in more or less any products, small scale edge compute. But it's also, as I mentioned, it's going even smaller. So what's the difference between Edge AI? I guess everyone is doing cloud AI. Obviously, you use ChatGPT or you build some smart application using some large models. But if you want to do Edge AI, it's not in the cloud AI, basically. So you move to your desktop or your laptop or your phone or anything else local, then it's Edge. It's also network Edge, but then it's a data center, a local data center. I'm, in this presentation, focusing on this smaller scale edge. But it's always local edge. So even if you get an internet disconnect, you still have intelligence locally. That's the main thing. You get intelligence here locally. So what's the major reason for putting edge compute and edge AI locally? So part of it is, of course, what I mentioned. It will be resilient to disconnects. But you also get lower latency. If you have, let's say, an industrial process, and you need to react very quickly, you need to have local compute. If you, let's say, you have computer vision, you want to take action within milliseconds or seconds, then you need to have local compute, because it might take a lot of time to travel back and forth to the cloud. Even though it's fairly low latency, typically it might be varying, and that's usually a disaster for tight control. Then, of course, bandwidth could be an issue. If you have cloud connectivity, maybe over a wireless link, it will be a problem with the bandwidth. So if you have like full 4K video or any other data where you get lots and lots of data, it's better to process locally. Of course, computing power is usually much better in the cloud. But still, today you can get quite sophisticated compute done locally also. And as I mentioned, I focus on this smaller edge. If you look at some of the AI type of services you might already have in your home or in the area, some of them seems to be local, but are actually cloud connected, like Siri or Google's smart home products. Typically, they go back and forth to the cloud, interpreting what you said, and then send back some response. While some of the more autonomous ones actually do local AI, like Husqvarna Auto Mowers. It could be your smart camera with automatic processing in the camera to detect objects. Or it could be like variables that actually process some data locally to discover your pulse or other local aspects of your body. So it's really lots of things that seem to be local are not local. So that's kind of the intro, what I mean by edge AI in physical products. Now I'm going to go in a little bit on technical foundations like hardware and software. So as I mentioned, microcontrollers are growing very, very rapidly. So you can buy small system on chips with quite a lot of capabilities. And there you can do, let's say, small type of process. You can do really small ML models that do, like in the cameras, like process an image or some audio to detect some deviations or calculate the pulse in your clock or something like that. Then we had the mid type of devices. These are more like our mobile phones. I mean, compared with your laptop 10 years ago, it's probably as powerful. So it's quite powerful. You can do lots of processing, including quite sophisticated real-time analysis of images and all sorts of things. But then also we have the really large edge. Like if you own let's say a sawmill or something, you could put a complete rack with GPUs, some servers, and then you had a very powerful kind of almost data center style edge. So it's really a wide variety of edge hardware. Cloud is more the same, more similar, but even in the cloud there are some differences. If you have edge devices already, obviously you can buy NVIDIA stuff and put in, but there's plenty of other types of accelerators. This is a Google CPU, so if you have a Raspberry Pi, add this, you can make, let's say, image recognition or object detection 10 times or even more faster. So it's fairly easy to add external additional AI to your local compute. And this is happening quite a lot. If you look at, for example, the Mac Studio recently released by Apple, you have a significant amount of compute there. You have like 512 gigs of RAM that you can use for the GPU. So it's kind of moving. And NVIDIA is also releasing their Spark, significantly powerful edge computing. But we also see all these small microprocessors, the system on chips, they are adding edge compute, like AI accelerators to even the really small chips. And then, of course, the software stack, it's less similar to the cloud. So all the training and all these types of things, like creating your AI model, is typically very similar. It's like the TensorFlow and PyTorch and all these. But then, depending on what type of hardware you have, there will be more and more differences. In some cases, if you buy a small microprocessor, you will get the complete stack from the manufacturer, and then, in the worst case, be locked in to some very specific AI software toolchain. So we are at RISE working quite a lot of trying to look into how can we build a software toolchain or compose a software tool chain that is open, so you can actually replace your microprocessor to some other manufacturer's processor, but still keep your software and AI models. Then, of course, I guess you know, this is Eriksson land, so 5G, 6G is also standardizing how to do edge compute. So there's a couple of companies like the one on the picture here, Fiskarheden, they're doing a complete 5G network, private 5G, and they're adding, let's say, small edge data center. And 5G, 6G infrastructure is defining how to deploy edge AI also. So this is kind of getting standardized, which is very interesting, because that will also open up the door for more manufacturers and open source in that space. But then, of course, if you like cloud AI, you have more or less infinite resources. If you go edge, there will be a smaller amount of resources for your compute. So it will be smaller models, less precision on them, but it will still be quite sophisticated. Of course, in some cases, if you build a product using edge compute, you have a limited energy also. So if you, let's say this auto hour, or if you have a small camera on batteries, every type of processing you do with AI will consume more of the power. So that could be a limitation also. And as I mentioned, in the cloud, it's a little bit more similar, independent of what cloud and what AI you're using. While on this embedded AI or edge AI, it's more fragmented. So it's more complex to set up your hardware and software stack. And of course, you add some security risk also, because the cloud is not reachable physically typically, and they have quite good security. If you do edge computing, it might be the case that someone can reach your device, so you need to consider the physical protection of the device also, which is a completely other story. So you add some risks also. And I'll move quickly into some of the use cases. We have one project that's really interesting, and I mentioned this open source tool chains for edge AI. This project is quite a lot about that. And we tried to build smarter, let's say, add smart features to Husqvarna's auto mowers in that project. Using the regular, they have a lab auto mower that you can see on the picture here, where we play around. This is at an open house we had. We're kind of working locally, so it's 200 meters from here. And we are basically cutting some grass in Kista to add some data sets to do some AI training to make some smart features. We do have Assa Abloy in the project also, so we try to look at smarter doors, like detecting if people are actually walking into the door or maybe just passing by, because this is a high cost, especially in the winter when you want to keep the warmth in. And then you let it out. If someone just walked the dog, pass by, you lose some energy. So it's really focused on implementing AI using open source tool sets here. Then, of course, we have the smart cameras. We have the Axis company in Sweden that produce cameras where you can deploy your own AI models, for example. So this is a hot topic. You can buy lots of low-cost Chinese cameras also, but then maybe there's a risk involved also. But you can deploy AI models in these also. And then, of course, not really in the sawmill like in these products, but this is edge AI in control. We're looking into how to maybe stop the process when something is going wrong, like it's getting to be complete mess here. So before that happens, a few will be in a mess, and then you can stop the production, fix it, and continue. And then you don't get these long stops. So that's also trying to use edge AI for control of a specific industrial process. And then the final use case here I will mention is or almost final, is something we just got recently. It's actually funding for others to work with us on edge AI in space. So this is a really cool topic. And you can get back to us to discuss this, of course, or other topics, and we can give you more information about this. This happened just recently. Finally, it's a little bit of the scary use case, where we see all these drones in wars actually fighting the war, and they're adding edge AI to actually be able to fly and do the mission without having GPS or communication back to the person in control, because it's always kind of these electronic disturbances and all sorts of things, so you get disconnects and other problems. So this is a scary use case, but it's happening right now. So why should you add the edge AI to your product? Of course, it's going to give you resilience, advanced local control, autonomous operations, and many other aspects. We'll also create a product that is more software defined. You can add more compute, you can add more features if you have edge compute in it, rather than it's only connected to the cloud or have some very basic software. And it's also, if you add machine learning online in the device, it will also adapt to your local environment, so you can actually get it to know your garden better, or whatever it could be, like seeing the flowers and avoid running over them and learn where you usually have the flowers, and that type of thing. Could also be because your competitor is adding it. That's also kind of a reason. We see lots and lots of products coming out with AI features. Then, of course, security. This is a super important topic, of course, which is something we are also working very actively on. So when we bring edge AI in there, we get more sophisticated devices that can do more, and therefore are more interesting to hack, basically. But you also get some nice features. If you send all the data to the cloud, and you have let's say, someone hacking the cloud, you lose a lot of data, and maybe it's not even allowed to send it to the cloud. So in a sense, you also get the privacy part. You can have local data processed locally without the risk of getting the data into others' hands. So how do you manage this? Yeah, this is going to be a super important topic, especially for the more advanced devices that we see coming. And these are kind of general cybersecurity threats that are stories that have been happening to, small-scale IoT devices can be a bridge into your complete network. We have some, probably you remember the Coop disaster, where they could basically not sell anything anymore. So it's really already happening, and when we add more sophisticated devices, it will be more sophisticated risks also. It could be about someone accessing your devices to get the data. Could be if you have that type of, let's say, video material in the devices that you process, someone can get that. Could be just sabotaging. Let's say your device will be hacked. That's maybe the worst case of the security disk. It would be causing problems. Of course, a garden device that is hacked, or some vacuum cleaner, not a big disaster, but we see some new devices coming, like all these humanoids. I don't know if you've been looking at YouTube, but there's a lot of videos with humanoids coming now. So in some few years from now, there will be lots of these. And then you should definitely ask yourselves, whose humanoid would you dare to buy? Would you buy Google's? Would you buy Facebook's or Meta's? Would you buy Tesla's humanoid or a Chinese one? This is really scary, because if your humanoid gets hacked, these ransomware attacks for others like Coop or others, it looks like nonsense. It will be about a humanoid maybe with some scary equipment in their heads threatening your family or something. It will be a completely new type of security threats. So this is something we should definitely look into, what will happen in the future. And then, of course, maybe you've tried Claude and these MCPs. You can plug in control in these also. I've been doing some, just for fun, connecting my IKEA equipment so I can control all the equipment through Claude. So I can ask about temperature in my attic and ask about mold risks. I can also ask it to turn on my light in the rainbows, all colors in 16 steps, and it will be doing some nice lighting effects. So it's really lots of exciting things happening. And that was my last and final slides. And this is actually another Edge AI thing that we did on our open house. It was handing out candy to all our guests. Thank you.